Welcome to Algebra, solving systems of inequalities. As you may recall from an earlier lesson, an inequality has more than one solution. For inequalities with one variable, such as x less than -4, the graph is shown on a number line like this with an open circle on the value -4, and a line going to the left, indicating all the values that make this inequality true, such as -4.5 or -7 or -9.9, all values less than -4. Another inequality, such as x is greater than or equal to 1, is graphed using a closed circle to indicate the possibility of a solution equal to 1, and a line to the right showing other possible values that also work, like 5 or 8.6. To graph the solution to an inequality with two variables, such as 3x plus 2y greater than 10, we first transform it into slope-intercept form by moving the x term to the right side, dividing all parts by 2, the coefficient of y, and then showing it in a graphing application such as Desmos. The Texas star version of Desmos doesn't allow using the greater than symbol or any of the other inequality symbols. So we must use the equal sign, and then think about which area of the graph should be considered. Since the symbol being used is greater than, the area above the line is our solution, and we shade it in. Also, we use a dotted line since the inequality is only greater than and not equal to also. Now we just need to consider some points inside the shaded area that would be suitable, such as 0,7, 4,3, or 3,1. To test these points, we substitute them back into the original inequality, work out the expression, and see that each point does indeed work. Here is an actual question from the 2021 STAR test, asking which ordered pair represents a point that works with this inequality, 8x plus 16y greater than 32. Transforming the inequality to slope-intercept form, subtracting 8x from both sides, and then dividing all parts by 16, resulting in the inequality y greater than -1/2x plus 2, allows us to graph this in Desmos to see which points lie in the solution area, the part above the line, which is dotted since the inequality does not include equal to. As you can see, the only point that works is -3,5. And substituting it back into the original inequality shows this to be true. 56 is indeed greater than 32. Testing the other 3 points clearly shows they don't work, with the point -1, 1 clearly outside the shaded area, resulting in a false statement 8 greater than 32. And the other 2 points, 0,2 and 4,0, being right on the line, don't work either, both resulting in the false statement 32 greater than 32. Now that we've reviewed how to work with one inequality, we can do the same with a system of inequalities, two at the same time, as shown in this 2022 STAR test question. We transform each into slope-intercept form, use Desmos to graph each one, remembering to use a dotted line since neither inequality uses the equal to part of the symbol. We examine the shaded area for each, observe the overlap, and then see that it matches, choice C. Here is a system of two inequalities shown in standard form, 2x plus 5y less than 30 and -5x plus y less than -6, which we transform into slope-intercept form, y less than -2/5x plus 6 and y less than 5x minus 6. Graph each one using dotted lines since both are using less than as the comparison operator. Also listed are 4 points scattered across the graph, one in each of the 4 areas created by the 2 lines, 8, -7, 1, 10, 6, 5, and -3, -10. We show the shaded graph and see both areas below each line shaded in, with the overlap in the bottom right section. We want to determine which of the 4 points is in the overlap area, and we readily see that the point 8, -7 is the one. However, Let's look first at how each point works into the two inequalities, see the results, and mathematically determine which point works. We first look at -3, -10 in the lower left area. Substitute the x and y values into each inequality. The first inequality works out to be correct, and you can see that visually, since that point lies in the shaded area for the first inequality. However, the second inequality shows a false result, indicating mathematically that it does not work, and visually it is not in the shaded area for the second inequality, and so we eliminate this point as a choice. The next point we'll try is the one in the upper left area, 110, which clearly is not in either shaded area, and mathematically does not work either, since the first inequality shows a false result, and so does the second. We eliminate this choice as well. The third point we'll try is the one in the upper right, 6, 5, which clearly is in one of the shaded areas, but is not in the other. Substituting the x and y values of this point shows the first inequality result to be false, but the second one to be true. Nevertheless, we eliminate this point. The fourth one, 8, -7, works out mathematically in the first inequality, as well as in the second, and so we have shown this point works, both visually, seeing it in the overlap area, and mathematically, correctly showing both inequalities to be true with these values.